This is a video that I'm submitting to AHEC, just giving an overview of what I do at Chandeska Community College as science faculty. So my name is Brent Voels. I have a doctorate degree in biochemistry and molecular biology, and I've been teaching at Chandeska Community College for 10 years now. This is year number 10 for me. And the main thing that I really enjoy doing with students is all the different activities that I can offer to them that include research opportunities, many hands-on experiences, and things that can really propel them forward in their future careers. So I'm starting out the video just looking around at the research laboratory in the background. And so this is where my current two research students that started working with me in the summer of 2023 are operating out of. And you probably have some videos from them that are detailing the different techniques that they undergo. And so this is kind of one of the labs that we work out of, that we do the DNA extractions in here, run the agarose gels, and then visualize the gels, and all that happens in here. Currently, my two research students are actually working on 3 individual projects when you actually evaluate what's going on there. So right now, they're working on 3D printing weather stations. So they've been very much so working hard at that. It's quite a bit of troubleshooting. If you've ever worked with 3D printers before, they seem to always be breaking or just acting a little funny. And then the other project that we're working on, as you can probably see from all these little cup containers, is they were going out and catching pollinators during the summer months. And after we capture and catalog the pollinators, we then take them and they undergo a dissection of their gut microbiome using this equipment here. You can see the tools that they're using. And we are extracting their gut microbiome and then using a column kit to extract all the DNA from that. We then utilize different primers to confirm the species of the insect that was captured. And then we use a set of other primers to analyze that pollinator's entire microbiome, including what type of pollen they might have been consuming. And this starts to overlap with the weather station project in a sense too, because the analysis of the pollinator's microbiomes is going to give us a fingerprint of what the pollinators in this area are like now. And then in the future, as these studies continue, hopefully at least other scientists carry this on, even if I'm unable to, we will see how their microbiomes might be changing in response to changes in the climate. We also have that third project that the students work on where they're going out and capturing mosquitoes so we can verify and analyze their relative abundance of each species during each month. And that'll also play a role linking back to climate variables as well once we get those weather stations running, because it'll allow us to use the weather station data to pair with changes in either pollinator prevalence or mosquito prevalence. And a little interesting tidbit if you didn't know this, but mosquitoes are actually pollinators too. Mosquitoes actually only feed on a blood meal when they need to lay eggs. Other than that, they function as pollinators in the ecosystem. And this type of research really links back to overall human health, because our health is really dependent on having a healthy environment for which humans can live and exist in, and that requires a certain amount of biodiversity. We know that a huge percentage of our crops are actually dependent on pollinators, so it's really important that we understand what's going on with our pollinator populations as climate change starts to impact them. And that kind of wraps up just the overview of the type of research that I'm doing here. I love working with research students and teaching them all these new techniques and giving them plenty of hands-on experience, and hopefully it propels them forward whatever direction they choose to take their career.
Okay, so we're gonna dissect the bees into labeled tubes. Labeled PBS with the specimen number. PBS being for the guts and the body parts go into isopropyl alcohol. So we'll start dissecting. Here's the specimen number, 87. Here's my 87 tube. So I'm taking off the legs. These go into the body part tube. Now the wings. Now I'm gonna get the guts. I make an incision in its abdomen. Here's some guts. Guts go into the PBS. Do a quick check, make sure we got all the guts out. There's a little bit. Throw it out in there too. Guts are done. Now body parts go into isopropyl for long-term storage.